Now we're going to do question 10. 10.1 says that you're given a triangle of ABC and the following points, and you're asked to prove the theorem which states that AD over DB is equals to AE over EC. So we are asked to prove the theorem that says that AD over DB is equals to AE over EC, right? So it's AD over DB equals to AE over EC. So this is what we are required to prove, right? So the first thing you're going to do is you're going to construct, right? So we're going to construct a line that goes like that and goes like that, right? And we say it's perpendicular there, and we call this H, right? And then construct another one going that direction and that direction, and we call this K, right? So let me remove this. Ones here. So now, now that we've established our perpendicular heights, let's find the areas. So we're going to find the area of this portion of the triangle at the top, right, with its base being AD, right? And we're also going to find the area of this triangle here with its base being DB. So this is the part that we'll be looking at, right? On the left hand side is this portion here. So at the top is going to be the area of triangle ADE divided by the area of triangle DBE, right? So what's the top area of the triangle? It's half times the base is this one here, which is 80, multiplied by the perpendicular height, which is H, divided by half this bottom one now, multiplied by the base, which is this side, DB, multiplied by the perpendicular height, which is still H, right? So this cancel out, so we'll remain with AD divided by DB. So this is the first part, right? So now let's do the second part, right? So what we're going to do is this. So we're going to look at the blue line now. So we're going to find the areas of this section here and this section here, basically. So let me just cover everything in this top triangle because the base is AE. So now what you're going to do is this. We're going to say the area of triangle ADE over the area of triangle DEC, right? Equal to, so what's the area at the top? It's half multiplied by the base, it's this side here of AE, multiplied by the perpendicular height, which is K, divided by half, multiplied by the base here, it's EC, multiplied by our perpendicular height, which is K. So this goes away, so you remain with AE over EC, right? So this is number 2, right? So now we are having the following. So let me just write it nicely on the other side. So we are having the following now, which I labeled as equation 1. We are having AD over DB, right? Equation 2, we are having AE over EC. So these two must be equal. So something must happen for these two to be equal. Let me first erase here. this is what you need to note. For us to make these two, equation 1 and equation 2 being equal, the following must apply. So let's look at the bottom part. The bottom part, we're having something that looks like this, and we have lines that look like that, and then we have this, we have something that looks like this, right? And then this is the line, and this is the line, right? So you have something that looks like this, and this is E, this is C, this is D, this is B, right? So what you need to notice is this. These lines are parallel, right? So this is parallel to this one, right? So when you have parallel lines, right, and the shapes, the triangles, this triangle here, the one that I just shaded, this triangle here of DEB is sharing the same base with the other triangle. I'm just going to shade in green. This triangle here, they share the same base. The base is DE. So the fact that we're having these two triangles that are between parallel lines sharing the same base, it means now that the triangle BDE is equals to triangle CED. So it means now that these two triangles, this triangle that is green and this triangle that is yellow, they are equal because they are between parallel lines and they share the same base, right? So if these two triangles are equal, it makes even the top triangles that we found here using these perpendicular heights equal. So once these two are equal, or these two triangles rather are equal, therefore it makes our equation 1 and our equation 2 equal. So we can just conclude after proving that. We can simply say, okay, fine, so these are equal. So the reason for that, so we need to write the reason. So reason would be that DE is parallel to BC, right? And yeah, you can say same base, share same base. So that is the reason for this portion here. And then you can conclude and say, therefore, AD over DB is equals to AE over EC. So that would be the final solution for this problem here. Now we're going to solve this one here. So we're having a parallelogram and we are told the ratios of BJ and JC. So these are the ratios, and we are told they're parallel lines. We are just told all the information about parallel lines. As long as you know the properties of a parallelogram, then you shouldn't have a problem with this problem here. So we are told that BJ, so BJ, this is BJ, it's 2, and here it's 3. So these are just ratios, they're not lengths, right? So 10.2.1a, we are asked to find ML over LC. So this is ML, right? So meaning the ratio of ML, it's going to go with this 2 here, right? If you take a look, we are having the triangle that looks like this, and this is M, this is L, this is C, this is B, this is J. So these are parallel. So when these are parallel, then the ratios would be equal, right? So ML over LC is equals to BJ over JC, which is equals to, what is BJ? It's 2. What is JC? It's 3. So this would be the solution, right? Yeah, so you can write the reason for this is line parallel to one side of triangle, right? So then now we go to the B part of this problem here. So we are done with this one, A. Now we're going to B. AK over KJ. So this is AK, so let me use this color. This is AK over KJ, right? So for us to find the ratio of this one, it means we need to find this ratio, AM and MC, right? Why? Because this portion here goes along with this portion here, right? Cool. So so this is what we're going to do. So to find that, let me erase everything here. Cool. So to find this, we know very well that this portion here and this one here, right? And we know that BJ and JC, BJ is 2 and JC is 3. So meaning that the same here, it's 2, here it's 3, right? So ML over LC is equals to 2 over 3. It's what we found previously. And we know that MC is actually equals to 5, right? So MC from this point of M to C is 5, right? And that 5 is actually equals to this portion here, from here to here, right? So MC is equals to AM is equals to 5. Why? Because let's just say PEM. You can say PEM because this is a perpendicular bisector. So this portion of the parallelogram is equal to this side of the parallelogram. So you can just say PEM, parallelogram. And so it means here it's also 5, right? So now we are having this. So let me show you. So we're having this portion here now, from here to here and here. So now we can find AK, and KJ, right? Because we're having this triangle that looks like this, right? And then there's parallel lines here. And this is A, this is M, which is 5, and this is L, and then here is 2. So we want to AK and KJ, right? So we can simply say AK over KJ is equals to AM over ML. So this is L equals to, so AM is equals to 5, right? This 5 here. So it's going to be 5 divided by ML, which is 2. So this would be a solution for this problem here. And we can simply write the reason as line parallel to one side of triangle. Cool. So now let's go to 10.2.2. We are given AB being equals to root of 10 units and BC being equals to 2 over 3 of AB. And you're asked to calculate the length of AQ. Okay, so we know that AB is equals to the root of 10 units, right? And we know that BC is equals to 2 over 3 of AB, right? So if we were to find this BC, because we know AB, so it's going to be 2 over 3 into root of 10. So now we know BC, which is this one here, which is 2 over 3 root of 10. And remember that this BC is equals to this AD. So BC is equals to AD. The reason you can say PEM, parallelogram, right? That's your reason. So meaning that AD is equals to 2 over 3 root of 10, right? Multiplied by root of 10. So now that we have AD, and remember we want to find AQ, which is part of this AD, right? So what we will do is this. So AQ is part of AD, as you can see. This is what we want here. So AQ is half of AD, as you can see. It's half of AD. Why am I saying that? Remember that this is a parallelogram, and from here to here it's equals to from here to there, right? So these are equal, right? So so half of AD. So what is AD? Half of AD, it's 2 over 3 root of 10, right? So this 2 goes away. Then AQ is equals to root of 10 over 3 units. Right, so this is the solution for AQ.